A squared plus B squared equals C squared. That's the Pythagorean theorem, right? But what does it actually mean? Well, here we have a right triangle, and A is one of the short side lengths of the triangle. B is the other short side length, otherwise known as legs of the triangle. A squared plus B squared equals the long side, the hypotenuse, squared. A squared plus B squared equals C squared. The lengths of the legs of our right triangle here are 3 and 4. The lengths are 3 and 4. 3 squared plus 4 squared equals our hypotenuse squared. Now we solve for C to find the length of the hypotenuse. 3 squared is 9. 4 squared is 16. 9 plus 16 equals 25. 25 equals C squared. The square root of both sides gives us C equals 5. So the length of our hypotenuse is 5. A right triangle has a hypotenuse of 13 and one leg measuring 5. What is the length of the second leg? So this is a reordering of the Pythagorean theorem where we already know what C is, and we're trying to solve for one of the legs. Pause the video and solve for the second leg length, then keep watching the video for the explanation. So we have 13 squared equals 5 squared plus B squared. 13 squared is the hypotenuse, and again, A squared plus B squared equals the hypotenuse squared. So we have 5 squared, which is 25, plus B squared equals 169. Subtract 25 from both sides to isolate B squared, and we have B squared equals 144. Take the square root of both sides here, and we get B is equal to 12. So the lengths of the sides of this triangle are 5, 12, and 13. Now you can use the Pythagorean theorem to find the lengths of any side in a right triangle as long as you know the two other sides. But the CLT and any other standardized tests love testing Pythagorean triples, which is just a fancy word or phrase for common side length ratios of right triangles. Remember, our first example, we had a triangle with side lengths 3, 4, and 5. Well, that is a very common right triangle to see on a standardized test. Side lengths 3, 4, and 5, or 6, 8, and 10, or 9, 12, and 15, 12, 16, and 20. Those are all similar triangles. They have the same ratios of the sides to the hypotenuse. So a triangle with leg lengths 6 and 8, you should automatically know that the hypotenuse of that triangle is 10. And if you see a triangle with a hypotenuse of 15 and one leg length of 9, you should automatically know that the second leg length is 12, because it maintains the ratio 3 to 4 to 5. And let's talk about a couple more. 5, 12, 13. That's question 2 that we just went over. 10, 24, 26, and so on. 15, 36, 39. Triangles will have those Pythagorean triples, those side length ratios, all the time on standardized tests. So what is the length of the second leg of this triangle? It is a right triangle with the hypotenuse measuring 39 and the first leg measuring 15. What is the length of the second side? Pause the video and solve it, but don't use the Pythagorean theorem, use the Pythagorean triples. All right. The answer is 36 because this is a 5, 12, 13 triangle just with a longer hypotenuse. So 5, 12, 13. In order to get to 39, we'd have to multiply by 3. In order to get to 15 from 5, we'd have to multiply by 3. And in order to get to the correct answer, 36, we'd multiply 12 by 3. So we're keeping the ratios the same. There is one more Pythagorean triple that you will see, which is 8, 15, 17. And you should know that one off the top of your head because it's very, very difficult to do this math without a calculator on the CLT if you don't know that 8, 15, 17, 16, 30, 34, and so on is also a Pythagorean triple where a squared plus b squared equals c squared. Just to quickly verify that, we have 8 squared plus 15 squared equals 17 squared. That's 64 plus 225 is equal to 289, which is correct, and we can draw this triangle. That is a special right triangle in a certain sense because you will see it, and you might see a triangle with a leg length of 16 and a hypotenuse of 34, and you will be expected to know off the top of your head that the second side length is 30. So you need to memorize these ratios: 5, 12, 13, 3, 4, 5, and 8, 15, 17. Now let's do a practice question, and remember, you're expected to do this question in your head without ever doing any math on a calculator or on a piece of scratch paper. A 26-foot ladder leans against a wall, reaching a point 24 feet up on that wall. How far is the base of the ladder from the wall? Pause the video and try to solve this question. All right, so you should have drawn a triangle because the ladder is a straight line going from the ground up 24 feet on the wall. The hypotenuse is 26. That's the length of the ladder. It is 24 feet high on the wall, and you should have noticed this is a 5, 12, 13 triangle, which is one of those special Pythagorean triple triangles, and the length from the base is 10 feet. To practice more Pythagorean triples and other topics on the CLT, get the free study guides at app.classictestprep.com.